Okay, good day everyone. We will be discussing about fuel efficiency in marine propulsion. So fuel efficiency in marine diesel propulsion is a key factor in reducing carbon emissions, operational costs, and environmental impact. So with increasing regulation from the IMO and global efforts toward decarbonization, improving fuel efficiency has become a primary focus for ship operators. So how do we really uh, use our fuel? So if this is your diesel engine and this will be your combustion, okay? So this is the fuel, your fuel. If you put the fuel inside the diesel engine, it will produce its power, right? So most of its energy, so this will be our if this is your engine, so not it's not 100% of the power that produced by the fuel is converted into mechanical energy by the engine. So there are some losses, of course. So with those losses, so we there is little efficiency on our fuel. So to make it to increase our efficiency of our fuel, so as you can see in this diagram, we have a diesel engine. Some of its exhaust gas can be used to start or to start or to run a turbocharger. So this turbocharger is the one that rotates, and on the other side of the turbocharger there is a compressor in which uh, fresh air will be introduced inside the diesel engine to increase its power output. Okay, so that's another way to increase your fuel efficiency. Another way is if you have another exhaust gas, you can put it into a power gas turbine, and then if that turbine will run, so part of the energy of your fuel is converted into electrical energy or other types of energy. So that's why we can say that there is an addition of efficiency in our fuel. So you can put it here. Okay, so N is the efficiency. So efficiency of the diesel engine, and then combined with the efficiency from the power turbine. Okay, so this power turbine will generate electricity for the ship. So another part of that exhaust will go to another one, which is a steam generator. So this steam generator can produce electricity, or if you put that steam into a turbine, so that turbine will produce electricity, and then it will give another efficiency, or in our total efficiency, or our combination efficiency. Okay, so these are just a simple concept of combined ship power system. So this is the efficiency from a steam turbine, efficiency from a power gas turbine. So actually we still have turbocharger, we still have what this one will be the economizer in here. So yeah, so the exhaust gas in our diesel engine can still be used to increase the fuel efficiency in our marine propulsion engine. And there are so many ways to increase our fuel efficiency. Okay, so let's go next. So modern technologies and innovations aim to maximize energy output from every unit of fuel while minimizing waste and emissions. So helping ships comply with IMO 2023 EEXI, Energy Efficiency Existing Ship Index, and CII, Carbon Intensity Indicator Regulation. So these are the EEXI. So Energy Efficiency Existing Ships Index, improving the technical performance of existing ships. So how do we improve that? So this EEXI certification entered into force in November 2022. So all ships are required to calculate their attained energy efficiency. So they have to calculate their existing ship index. And the EEXI is a one-time certification for existing ships targeting design parameters. So there are a variety of technical means to improve the carbon density of existing ships and achieve the required EEXI. So a review clause requires IMO to review the effectiveness of the implementation of the EEXI requirements by 1st of January 2026 at the latest, and if necessary develop and adopt further amendments. So with this, we are inclined, or we are inclined into modern technology and innovation. So that's to maximize our fuel efficiency. Okay, next. So here's an example. So key innovations in fuel efficiency for marine diesel propulsion. So what are the innovations that we will be using to increase our fuel efficiency? First, we have the electronic fuel injection and fuel optimization system. So in principle, it replaces conventional mechanical fuel injection with digital control for precise fuel metering. So what are the benefits? So it reduces fuel consumption by optimizing injection timing, improves combustion efficiency, reducing unburned fuel and emissions. It lowers CO2 and NOx emissions to meet IMO Tier 3 requirements. So some examples are common in modern 2-stroke and 4-stroke marine diesel engines, improving efficiency by 5 to 10%. So in this diagram here, we have a common rail injection system or common rail fuel system. So in this common rail fuel system, there is a pump. Okay, so we have control unit, and this control unit gets information from different sensors like speed sensor, the exhaust temperature, the the inlet air pressure. So there are different sensors that it is getting information from. So this control unit will give signal to our pump. So this pump will be the one that will be giving high pressure, or will be building up pressure into our common rail. So this red one is the common rail. Okay, so we will be building let's say a 1,000 bar or 2,000 bar or 3,000 bar of pressure in our common rail system. And then this pressure, so there is a pressure limiter here, in which the pressure will be limited on to prevent sudden pressure on our injector, so to prevent damage or rebounding of the pressure. Okay, so there is a pressure limiter here, and the pressure will be maintained at here for our injector. And then depending on and then we have here a sensor to maintain the pressure in our common rail. This is the common rail, the red one. And then we have here a relief pressure. So if ever the pressure overcomes the set pressure, or depends on our set point, so too much pressure is also not that best for our system. So the extra pressure will be going back to our fuel tank. Okay, so the fuel in here is sucked by our pump. Okay, so if the engine will run, depending on the control unit, so it precisely with its digital control and precise fuel metering, so this control unit will be the one that will be controlling the injection timing, the injection pressure, or the injection, how long the injection will take place, and all the necessary configurations in our fuel injection. So in this way, we can optimize our fuel system, and we can increase the fuel efficiency of our marine diesel propulsion engines. So above, we have an example of an injector, which is electronic fuel injector. So as long as there is no current in our solenoid, so this valve here, the valve spring and the plunger will be closed. But if you supply an electricity on our solenoid, so this plunger will be magnetized using electromagnetic force, magnetized, and will be pulled back by the solenoid, and then fuel can now enter into the spray tip and then spray into the engine. So since it is electronic, it is easier to control. You can control how long it will take to inject, and how fast, or the timing or you can advance or delay the injection depending on the um, measurements of the sensor and depending on the control unit. Okay, so that's how they do it. Next. So next. Okay. So next we have the slow steaming and engine derating. So in principle, operating the engine at reduced speeds with lower RPM to decrease fuel consumption. So as long as you can reach your destination on time, so it is not necessarily important to always push your engine to the limit to full speed ahead always or all the time. So if you want to decrease the fuel consumption, we can operate the engine into a slow steaming speeds or reduced speed. So what are the benefits? It reduces fuel usage by up to 30% in large vessels. So extends engine life by reducing wear and tear. So if your engine has low low running hours, so also the maintenance will be lesser. Okay, reduce carbon footprint by minimizing fuel burn. So if you will be using lesser fuel, so there will be a more complete combustion during inside the engine, so there will be less fuel um, um, unnecessary burning and less carbon footprint. So let's see how this works. What are the examples in here? So first we have here the picture in here with the electro assist turbocharger for slow steaming. So if ever your engine will be running in slow steam or slow reduced speed, then you will be we will be having lesser exhaust gas that will be the one that will rotate our turbocharger. So if that happens, also the intake of our compressor will be lesser for the engine. So to reduce to increase the efficiency of our engine even in slow steaming, so we can use this technology, electro assist turbocharger for slow steaming. So if ever the speed of the turbocharger slows down to a specific level, automatically the motor generator will run, boosting the speed of our turbocharger. But if the turbocharger is very fast or is at its normal speed, so this motor generator will be creating electricity. So this electricity will be added to our fuels to our electrical supply for the engine and for the control room, for the ship. So it will also add electricity. So this is a dual purpose motor and generator. So if the speed of the turbocharger slows down, it will assist our turbocharger. But if the speed of the turbocharger is at its normal, this motor generator will be generating electricity for the ship. Okay, so this is an example of our innovations in fuel efficiency. Next, we have the slide type fuel valve for slow steaming. So they are tweaking a little bit on our fuel valve to accommodate or to have a better performance during slow steaming. Okay, next we have the turbo cutout for slow steaming. So if ever you have, for example, let's say that you have 3 turbochargers, and then when you have to slow steaming the engine, you will be reducing also your exhaust gases production. So if you have lesser exhaust gas, so your turbochargers cannot run efficiently. So there is a choice that you can cut off 1 turbocharger, 2 or 3 depending on your requirement. So you can cut off a turbocharger so that you can still maintain the proper optimized operation of a turbocharger. Okay, so we have valves in here. You can close these valves. So this is an example of this valve. This is like a butterfly valve. So this butterfly valve will be closed. So if this will be closed, the turbocharger will not run. So all the exhaust will focus on the other turbochargers. So you can also use this if there is a problem in your turbocharger. So you can still also use this one, right? So there's so much innovations in fuel efficiency for marine diesel propulsion. Okay, next. So benefits from slow steaming upgrade. So apart from running at part load, there are a number of ways to further increase the financial benefit from slow steaming. So these measures enable reductions in fuel and lubricating oil as well as an improved engine performance, adding significant further gains to the annual savings achieved by slow steaming itself. So such solutions are turbocharger cutout like this one. We have to cut out one turbocharger. Slide fuel valves are improved, alpha lubricator upgrades, and engine derating with the option of new propeller design. Okay, so these are the benefits from slow steaming upgrades. Okay, let's go to the next. Key innovation fuel efficiency for marine diesel propulsion. We have here the exhaust gas recirculation and water injection system. So in principle, it recirculates a portion of exhaust gases back into the engine to lower combustion temperatures and reduce NOx formation, like this one. We have here the orange one is the exhaust. It goes to the funnel. But part of this exhaust will be cooled down and then resupplied back to the intake valve. So the purpose is of this one is to lower down the exhaust gas temperature, or the lower the combustion temperatures. If you lower the combustion temperatures, you also reduce the NOx formation, or the air pollution that will be produced during your combustion. So what are the benefits? It improves fuel efficiency by optimizing combustion, helps meet IMO Tier 3 NOx regulations. It reduces the formation of particulate matter, enhancing environmental performance. So these are example. Another one to reduce our NOx formation is we can have a direct water injection. So it will be added into our injector, and then it will be sprayed inside the combustion chamber. So the purpose of this one, this will only be sprayed during the power or during the combustion process. It will not be sprayed during the compression and in the intake part or exhaust part, since the water will be detrimental, which will damage the liner, or will damage the lubrication in our piston and liner. So this one will be injected during the combustion. So this water will lower down the combustion temperature. So if you lower the combustion temperature, you also reduce the NOx formation in our engine. Okay, another key innovation, we still have one. Okay, alternative and low carbon fuels. So in principle, using fuels with lower carbon content or renewable alternatives to improve efficiency and reduce emissions. So what are the types of alternative fuels? We have the liquefied natural gas, LNG. It reduces CO2 emissions by 25% compared to HFO. Biofuels produced from renewable sources, offering up to 80% CO2 reduction. Methanol and ammonia, the future fuels with zero sulfur emissions and potential for carbon neutrality. So there are examples like LNG powered vessels such as Maersk methanol fueled ships are setting new industry standards. So there are different alternative fuel that we have. We have the LNG, we have the LPG, methanol, ethanol, biofuels, biomethane, synthetic methane or SNG, and we have hydrogen and ammonia. So there are different fuels that we can also use. Okay, another one, key innovations in fuel efficiency is hull and propeller optimization. So in principle, improving hydrodynamics to reduce fuel consumption by lowering resistance and enhancing propulsion efficiency. So one method is the air lubrication system, ALS. It injects air bubbles under the hull to reduce friction, cutting fuel use by 5 to 10%. So as you can see here, there are holes in here, and then air or compressed air or air will be introduced in this part of the hull, and then with this air bubbles at the bottom of the ship will be used as an air lubrication system. So there will be less drag from the ship's hull and the seawater. So there will be reduced friction, of course, and by reducing the friction between the hull and the sea water, So we are also cutting fuel by 5 to 10%. So another way of doing this is by using Venturi also. So there is a blower in here. So fresh air will be blown in this side, and then as the ship goes forward, seawater will enter into this hole, and then there will be a mixing of air and seawater. So at this part, so there will be an air lubrication system at this part of the ship, and there we are. We have a reduced friction and cutting fuel use by 5 to 10%. So this is another great idea. So at the top we have here 3 different blower. So air lubrication blowers. This will be the one that will be supplying air into this box 1 and box 2. So air bubbles will go at the bottom of the ship, so reducing friction. So this is a technology that the cruise ship are now using. So also because of this technology, there will be a lesser vibration in the ship, and the VIP clients will not be disturbed by the vibrations of the ships. Okay, let's go another one. We have energy saving propellers and rudders. So with advanced blade designs, reduced water resistance, and improved thrust efficiency. So as you can see here, we have a super stream duct in here. We have a surf bulb in here, and then the propeller is almost near the bulb. So this reduces water resistance and improve the thrust efficiency of our propeller. There are also designs like these propellers, which are used by what we call that, cruise, those little boats, ships, yacht. So they are using also this one type of propeller. And with the current technology, they have also this Voigt-Schneider propeller. So how does this move? So you can control its angle. So depending on the angle, you can push the water on this side or to the other side, depending on your angle of your Voigt-Schneider propeller. So with this one, you will not be using any rudder. So if you remove the rudder, you also remove the water resistance that comes into the rudder. So with this type of propeller, you can still maneuver your ship depending on your course without the rudder. Okay, so this is another type of propeller. So advanced blade designs, so these are the one. And there are so many advanced blade designs that they are using on ships, and so I cannot cover them all. Okay, next we have the hull coatings and cleaning. So if your hull will have too much fouling, so there will be so much barnacles in the hull, so there will be also higher resistance and friction in the hull and to the water. So if you want to optimize your speed and fuel efficiency of your ship, so you have to go to a dry dock and remove all those unwanted fouling, and then you should have hull coatings. And so this one is the cleaning, and this one is the hull coating. So special coatings minimize biofouling and improving speed and fuel efficiency on our ships. Okay, another key innovation in fuel efficiency for marine diesel propulsion, we have the hybrid and electric assisted propulsion. So in principle, it uses battery storage and energy recovery to supplement diesel engines. So benefits, it reduces fuel usage by utilizing stored energy during low power operations, enables zero emission operation in port areas, extends the lifespan of mechanical components by reducing engine load fluctuations. So example are hybrid propulsion systems in ferries and cruise ships such as Norwegian Cruise Line's energy efficient vessel. So we have here a diesel generator, dual fuel diesel engine. So if you run this one, you will give electricity into our propulsion motor to run the ship. But also, if you have another means, like we have a fuel system You have a ESS system. So this another system can also supply power to our propulsion, reducing the usage of our diesel or dual fuel engines. So it enables lower emission or zero emission at some point, and it utilizes stored energy, extends the lifespan of our diesel engine while still improving the fuel efficiency, of course, fuel efficiency for our marine diesel propulsion, and also giving our ships a good way or a greener way to run our vessel. Okay, so on the picture below, we have here an additional one. We have a solar panel. So this solar panel, photovoltaic solar panel, gives energy to our DC bus bar and go into our DC load. Also, this DC AC, there is a converter or transformer from DC to AC, so we can also start our AC load. So we can help our diesel generator from supplying energy into our propulsion motor or to our other machineries on board. So this is a good way to increase the fuel efficiency of our diesel engine. So we also have batteries. So the solar panel will charge the battery if ever there will be less usage of power solar into our into the consumers. So you can also charge our battery. So this battery can also be used to power our AC load or our suppliers, power supply. Okay, next, what are the impact on environmental protection and energy efficiency? So first, we have the reduced CO2 and NOx emissions, aligning with IMO 2030 and 2050 decarbonization goals. Okay, it lowers operational costs for ship owners by reducing fuel expenses. It ensures compliance with environmental regulations, avoiding penalties and restrictions. And it extends engine life through optimized fuel consumption and reduced stress on components. So there are many technologies that we will be discussing in our next videos also. And technologies were also discussed on our previous videos a month ago. So you can also check that one. So we have the carbon capture and storage system. We have the WESP or wet electrostatic precipitator and the scrubber system. So there are different ways to that will impact on environmental protection and energy efficiency. Okay, so as the fuel efficiency maritime decarbonization 2050. So as the shipping industry transitions to a low carbon future, fuel efficiency will be crucial. So parang ganito na ata yung mga barko natin. So this will be our future ships. So there are solar panels, we have hydrogen fuel cells, we have zero carbon fuel cells, hydrogen, and so many fully electric ships. So there are so many ways we have a better future, especially during the maritime decarbonization by 2050. So as the shipping industry transitions to a low carbon future, fuel efficiency will be crucial in achieving IMO's net zero emissions by 2050. So future advancements include full electrification of ships with renewable energy sources, hydrogen and ammonia fuel cells for zero carbon shipping, integration of AI and smart systems for automated fuel optimization. So this one was discussed on our previous videos also. So in conclusion, by IMO 2050 decarbonization, so fuel efficiency is a key factor in reducing the environmental impact of marine diesel propulsion. So innovations such as electronic fuel injection, slow steaming, alternative fuels, air lubrication, and hybrid propulsion contribute to lower carbon emissions and improved operational efficiency. So as the industry moves toward IMO 2050 decarbonization, further advancements in fuel efficiency technologies will drive sustainable and eco-friendly shipping operations. So this will be our future. IMO 2050 decarbonization, electronic fuel injection, hydrogen, slow steaming, air lubrication, hydrogen, and so much more. So I hope you learned something today. If you want some topics that we will be discussing on our next videos, please do comment down below. And thank you very much for watching. You can also comment down where you came from, so I will also know where did my video have shared some infos with from, or what place came you came from. Okay, so I hope you learned something today. Thank you. I hope to see you in our next video, and God bless everyone.